Alright, we've got an HSC question here. We're asked to find the value of a k, a coefficient of x here. Let fx equal x cubed minus 3x squared plus kx plus 8, where k is a constant. Find the values of k for which fx is an increasing function. Alright, I'm thinking increasing. That means it's got a positive gradient, which means I'm going to the first derivative. So I'm going to go and say that f dash x is going to be equal to 3x squared minus 6x plus k. Now, a little aside, we differentiate here knowing that k is just the coefficient of x. So we differentiate as we normally do, and our k will remain there. We're not differentiating with respect to k, we're differentiating with respect to x. So if I want to know it is increasing, that means that this is going to have to be above the axis always. Okay. Now, for that to occur, that is a quadratic function, which means I'm going to have to be thinking, well, if I'm thinking always above the axis, I'm thinking discriminant. So I'm going to go write down the expression for the discriminant here of this derivative function. So the discriminant of f dash x is b squared, so minus 6 all squared, remember to put the brackets, minus 4 times a times c, which is this case k. Okay, we've got b squared minus 4ac, which is 36 minus 12k. Well, if I'm going to need this here to always be positive, to be increasing, that means I'm going to have a definite. I'm going to have a positive definite. Now, to start with, it is positive. It's concave up. It's a positive, but I need it to be a positive definite, which actually means this discriminant here, this expression is going to be less than 0. Okay. Now, it might actually look like I've put contradictory things on the screen here going and saying these two things. What I'm saying here is if I want this to be always positive, if I want it always to have a positive gradient, well then my discriminant here of the first derivative must be negative. So we'll go and solve that, and we'll say that 36 minus 12k is less than 0, not equal to 0 as well. That means it's going to be a stationary point. So therefore I have minus 12k is less than 0, sorry, is less than negative 36, and k is greater than 3. I divide by negative 12, so of course I flip the sign of this guy here, and k is greater than 3. Now that makes sense, doesn't it? So if I think about this constant here, what that's doing, if I've got some quadratic, so this may look nothing like it, I'm just sketching quadratics here. If let's say that k was negative, let's say that k was 0, well there, it's clearly got a y-intercept at 0. If k was negative 5, it's going to look something like that. If k, however, is bigger than 3, it means that curve's getting just shifted up. Okay, it's being shifted up by more units. Now, as I said, these here in no way represent what the first derivative function actually looks like. But what it will tell us is that if k is bigger than 3 here, it means we're going to have that function up here always increasing.